Okay, welcome to Math 115. So I think what I will do is I'll just go over the highlights of the syllabus. You can read the document. It gets longer every semester, but I'll just tell you what I think is most important. So let me see. First of all, the textbook is free. You can get it online. Um, let me s- Okay, so what I want to talk about is how does this course actually work? So the way I teach is I give notes that appear, and I've asked Lincoln email asking me to print stuff out. So the notes are partially filled in, maybe 80%. The remaining 20% is left out for a reason. One is because statistics is actually best learned by writing down stuff. Uh, we may be in 2025, but these old school things actually still work. So um, my advice to you is I realize that people copy things at different speeds, and sometimes you want to listen to me and you find it difficult to listen and write at the same time. So I give you permission at any time to take a photograph of the screen. Now you may think, why don't I give you the complete slides at the end of the class? I don't do that because if I gave out complete slides, what would happen most likely is people would not copy anything, and it would be a very passive kind of learning experience where it's like, oh, yeah, I'm going to get the slides anyway, so I'm just going to listen. Well, maybe if you're in the 1% of people that listen and learn without writing, then that's good. But most of us, mere mortals, right, we actually learn by writing. And trust me on this, all right? So you can take a picture of the screen if you cannot finish. And sometimes I encourage students to do that because I'd rather you listen to me. But at the end of class, and this is very important, this is the first class, and I want to get all these important things down because I have taught this multiple times. So you are listening to someone that's giving you the best advice possible from other intro sets courses that I've taught. At the end of the class, look at your phone, fill in the missing parts of your slides as soon as you can after class, if at absolute minimum end of the week. You know why? Because if you don't do that, what will happen before an exam or before the final is you have how many photos do you have in your phone? 1,567, right? So try looking for lecture one, screen seven, something. Okay, that's not the way to learn. So my advice to you is at the end of the day, fill in the gaps by looking at your phone and filling in why. Because if you write stuff down, you learn better. Trust me. All right. Sometimes students don't trust professors. I don't know why. They're not trying to fake things. This is how you learn by writing, right? Math is not learned for most human beings by reading. You don't learn math by reading it or by looking off slides. You learn by writing stuff down. And this class also has a very, very large group work kind of thing, and I give physical things for you to write on. So we will be doing a lot of writing in this class actually, but I'll get to that. All right. Okay, so that's how class runs, and that's my advice to you. So there is a lot of group work in this class because this has never been something students did not like. So there's a group work component of 5%. So how this works is it's easier administratively to work with the group that is I don't know what's the word, the natural grouping that is found in class today. So the groups are usually of size 3, and they are usually your benchmates, right? So this being the first class, I am aware that some of you may know each other and you might want to be in a group with your best friend or something like that. I understand. So today, the group work will not be counted in that sense. But from the next class, if you want to sit with your friend, then come to class and do that. But retain the groups from now on. You know what I'm saying? So don't keep moving around like that. So the group that you have, if you don't know anyone in class and whoever you're with now, that's perfectly fine. I'm just giving you the option of making your own group if you want to, because this group is what's going to be your project group, your group work group, everything basically for 15 weeks. So um, but today being the first class, we won't count the group work in that sense. All right. So You will work with the people at your table because this just is great. The other advice I have is do not be a what's the American term, a Monday morning quarterback or something like that, right? Do not be a non-contributing sleeping partner to a group. You know why? Statistics is learned by doing. Because quite often, what happens in a group of three, one person knows how to do everything, right? Or knows how to do most things, and some people just disengage. So to help you and to motivate the whole group to work together, there's going to be a component called overall group work and final group project participation and cooperation 5%. What is that? Well, basically, it's you rate each other for how well you supported each other throughout the semester, not just when it's time to do the project. You get what I'm trying to say? So this is a continual thing. It is the impression your group mates have of you over 15 weeks. Why do I have to do this? Because I have found that there are classes I have taught where there are people who are habitually absent. Habitually absent. So they don't come to class. They only come to class on exam days. I'll tell you this. Only when there's an exam. I don't even know what they look like. Right? They don't come to class. They don't come for office hours. They don't participate. So if I put this in as a constraint, it will help encourage the group to work together. So if you are one of those that are thinking of skipping out, then know that you are making the group that you're in suffer. And the impression that they'll have of you is going to be pretty bad. Now, of course, if you're ill or something, I'm sure every group here will understand. But you know what I'm trying to say? There are people who habitually don't come to class at all. And so if you're in a group that has a member like that, it's not fair on the other members of the group. So that's why this component is there. So it's not just the participation at the end of the project, it's throughout. It's a continual thing. So what's your perception of this project? It doesn't mean you have to get everything correct. You see, that's not the point. The point is to be actively learning and helping each other out. There are tedious tasks like calculation, which anybody can do. So put your component in, and we should. This is never a problem actually. It's only a problem for people who don't want to participate and end up not learning. And I'll tell you this from my experience. I have never had a student that does not engage who does super well in the course. It just doesn't happen. Somehow, students who do well in the course also engage. I have never had. I'm sure there are people out there or professors that have had a brilliant student but has zero social skills and is very selfish, doesn't come for class and gets an A. It can happen in theory, but in theory, I've never seen it. So that's not how you learn. Okay, I think I've said this phrase 3 times. So I'm just putting this out there. All right. So group work, these kinds of, I don't know, paper-based group works that I give are graded by completion. So in other words, don't feel scared that, oh, I got this wrong. I want to see what you know. All I ask is that you do it. That's it. Then as you get more confident with the stuff that's here, then there will be group work that is graded. Okay, so that's how I usually ease students in. I don't give the graded one first. I give this low stakes, zero stakes actually. Fill it in by the group. Let me know what you think. So I won't grade this and give this back to you, but I will look at the responses and respond accordingly. Now, the other thing, which used to be quite good in the past, but lately has become slightly not so effective, is something I call Scratchpad. If you go to Moodle now, you will see that there's a Scratchpad for this class. Section 7 Scratchpad. One is a Google Doc, one's a Google Sheet. We won't use the Google Sheet just yet, but a Google Doc, yes. So this is a shared Google Doc for the class where we will do problems together on the Google Doc as well. And I invite you to participate, right? That's another way to learn. But I realize not every one of you can participate on the Google Doc. It gets really messy. And so that's why I have this paper-based thing to make it such that every group gets to write. It's all to help you, basically. Now, the Google Doc has some anonymity issue. So if that's an issue for you, so here's my advice. Because if you comment on the Google Doc, which I hope you do, your name will appear. If that's a problem for you, most students don't really care, honestly. But if you do care, then my advice to you is to open up another browser. Don't use another tab in the same browser. Open up a brand new browser under something else. The sheet is available to the whole world anyway. You don't need to be logged in as Hope. The point is not to be logged in as Hope on another browser. Then you just put the URL in and you can comment there. Then they'll give you some animal assignment or something like that. So your name will not appear. So if anonymity is important to you, you can do that. I don't mind. Okay, so that's the scratchpad that I was talking about. What's the data scratchpad? That data scratchpad is just a document that's a spreadsheet, because this is a statistics class. I'll be teaching you how to use spreadsheets and things like that a little bit. All right. So that's what you can expect. So what else shall I say? I think basically that's kind of it really at this point. So see, the what I was talking about here is this kind of thing. This is our class Google Doc, and I will sometimes place questions here. In fact, when you do these written assignments, what I'll do is after I collect them back, we will do them together on the Google Doc, and you can put in the answers that you wrote down here, and we'll discuss it together. That's how you know what you did, like that. All right. So I think other than that, I don't think there's very much else I want to say at this point uh, about the syllabus. Oh yes, I'm. So the homework is going to be electronic, so it's on Moodle, and it uses something called My Open Math. So that's external to Moodle, but you don't need to know these details. Just click on it; it will bring you there. Um, my advice to you is sometimes technology fails us, rarely, sometimes. So if you find that a homework assignment is not opening up for you for some reason, don't tell me after it is due when I come to class and tell, oh, by the way, can you reopen homework apps for me because it didn't open it? Yeah, where were you for 7 days and didn't tell me? Right? You know what I'm trying to say? I've had this kind of emails as well. Somehow the answers I put in never got registered and things like that. Yeah, tell me. Right? Because you make the professor wonder whether this is a legit excuse, or did you not do it and then you just the homework, you were 7 days, given 7 days to do it, but you wait till the eighth day to tell me that it failed. Why? Okay, I think you can sense the frustration, and because I've had many intro-sec classes. Okay, so don't do these kinds of things. It doesn't help you learn. And my homework assignments are not hard. They really are. This is an intro-sec class, and I know it's called Math 115, but really it should be called Arithmetic 115 because it's not really math. Yes, you will need to know how to use a calculator, right? There are formulas you need to know how to use. And that's why part of the reason is I'm going to give out this worksheet is I want to know whether any of you is struggling with using your calculator to calculate things. So you'll be surprised. I'm going to give you some things. The calculations are not, I wouldn't say easy, but I want to see if you know what I mean when it says use your calculator to do stuff. So that's what we'll do today. And as I said, this is a written one. So it's just by completion. I want to know what you know, basically. Right? And lastly, there will be an extra credit bonus homework that opens up today. Now, let me explain. I know a lot of professors give extra credit at the end of the course when people are kind of panicking. I'm giving it on day one. If you don't want to do it, that's up to you. This is extra credit. It's worth 1 point, right, out of 100. So this is like a plus 1 out of 100 points to your final total. It will be like any other homework assignment. It's basically an exercise in using your calculator. So I recommend that you do it. Even if you feel that you really know all the things, like why not? You can earn some extra points. I really would encourage you to do it. You don't have to, but I encourage you to do it because I want to know if you know how to use a calculator. Again, I'm coming from a place where I have met classes with students that do not know how to use a calculator. Maybe for very simple things like 1 plus 5 minus 3 divide and then entirely divide by 2 they can. But once you start having 4 or 5 numbers, they they just, what's the word I want? Zonk out. I don't know. They just can't, you know. They don't register where numbers go. And so that's what I'm trying to see if you have that problem. And at any time, if you have issues like this, please resolve them early by coming to see me for office hours. Do not let a problem fester. Early detection of problems is very, very vital. Right? I'm trying to help you succeed. This class, I know, is viewed and hoped by many students as like the pinnacle of mathematics torture or something like that. Believe me, it is not. Right? And yet it is a course that terrifies many students. And I don't really know why, because it's not really math. Right? The things you need to know are very basic. And I will be stressing them many times as you see as I go through the class. In fact, some of you who are whose minds are more inclined towards statistics may actually find some things a bit repetitious, and I do beg your pardon for that, because it is going to be repetitious, because there are some of us who take more time to process this kind of information. Statistics really is a frame of mind, a new way to think about things. It's not really about the math at all. Yes, there's some calculation. Yes, you need to understand formulas. Yes. But that's basically what it is. There's absolutely no calculus, hardly any algebra, really. And so you don't need to worry about those things. Okay, so I think all the important stuff that I want to say I have said already. So let's just jump right in. So you should have your chapter 0 notes printed out, and you can feel free to fill them in any way you like. You can use your device, you can write it out physically. Uh, so basically, what is statistics? Statistics with a capital S, with an uppercase S, is a science. Okay, with a lowercase s, then those are numbers. Like baseball statistics, health statistics. Those are little s. Those are numbers. Statistics with a capital S is a science. So we want to distinguish between anecdotal evidence and a proper statistical investigation. So anecdotal evidence comes from personal experience or some kind of striking example. It can be problematic. It's very tempting to use, but it can be problematic because it's not from a carefully designed study. It could be hearsay, or it could be your own life experience. And I mean, you hear all these things a lot of the time. You can say things like, "Oh, I know a friend who eats very unhealthily all the time, and yet has a healthy weight." You know, things like that. Okay, that's anecdotal evidence. It's not because you have seen thousands of people and done a careful study. It's just your friend, things like that. So it can be difficult to use anecdotal evidence to use as a backing for your argument, basically. Okay. So because it's problematic, because the data are collected in an unplanned way. And when I say unplanned, it's like things like, oh, I just asked my friends, or I asked my mom, or my aunts, or my dad, or something like that. So it's unplanned, it's convenient, you just got it from your contacts and things like that. Okay. And worse, sometimes it's a little bit more insidious. Sometimes people use anecdotal evidence, they cherry pick the evidence. This is really a bad thing. Okay, just using anecdotal evidence is not such a, I would say, such a statistical sin, if you like. But cherry picking cases is terrible, and many researchers are guilty of this. I don't know whether you follow the news academically anyway. Have you heard of cases where professors from really well-known schools have been discovered to have actually fudged the data and things like that? That's actually even worse. Cherry picking is you're not fudging the data, but you're leaving out data cases that don't follow what you want the conclusion to be. But this was really fudging the data. So all these are bad things. Okay. Now, what's a statistical investigation? It is a systematic, rigorous framework for learning from data, and it's implemented in this course in 6 steps. So don't worry too much about the 6 steps. We are not going to really enforce or expect you to memorize them, but basically the 6 steps are: before you analyze data, look at it, ask questions about it, then analyze the data, then ask whether the study could have been done better, what are steps to improve. So basically the 6 steps is a systematic way of looking at data. All right, so we will We will put this into context a little bit later. But basically, the moral of the story is it's very dangerous to use anecdotal evidence because it's unplanned, right? It's not that anecdotal evidence cannot be understood. It can certainly be understood, but it's dangerous to use because it's unplanned, right? Okay, so here's an example of why it is important to know how the data were collected. Okay, and I like to use this example because it's so often the case that in Holland, it's always, very often it's very cold. In fact, it's colder now, but it's usually quite cold anyway. And you know, in winter, most of us have skin that gets really dry. I don't really know why, but and I'm like that as well. So we tend to apply something to avoid our skin from cracking, put lotion on, or things like that. So let's say you wanted to compare the effectiveness of two kinds of lotion A and B. Like which one's better? And before you can say what's better, you need to have a metric, a way to tell what's better. So let's say there's a way to measure skin moistness or something like that. There could very well be a way. I'm not sure, but let's pretend there's some kind of device that you can actually put on your skin for a bit and then see how much moisture your skin has retained, something like that. So in that way, we can tell or whether A. Okay, so how do we study whether A is better or B? Which one leaves your skin more moist? So let's look at study design one. Okay, so let's look at this. Let's try to kind of evenly split. So one way to do the study would be I have the two lotion types. So I tell everyone on this side to use only lotion one on both hands, right? And do it every night or something like that. And then after 30 days, I'll take a reading and we'll see how moist your skin was and things like that after 30 days of using lotion. And you guys do the same, but only for B. Okay, that's one way. So that's study design number one. Another possible study design would be to get everyone in the class to try both lotions, but you use your left hand, you use A on your left hand and B on your right. So my first question to you is understand the design first. If I got, let's pretend that there are equal numbers of people on every side of the room here, and everyone has two arms. I think that's true, right? So let's say that we ask everyone, okay, under study design one, everyone does both arms only lotion A. And here everyone does both arms lotion B. Now study design two is everyone does A and B on one arm. Now my first question to you is, at the end of 30 days, do I actually have the same number of data readings for each lotion type? Think carefully before you answer. At the end of 30 days, when I measure all the arms for moisture or whatever, do I actually have the same number of data points for lotion A and B from both study designs if I were to implement both study designs? Think carefully before you answer. Is it yes or no? I see some of you nodding. The answer is yes. I do have the same number of data points. Do you agree? See, everyone here has two arms. Everyone has two arms. If everyone does lotion A only, I'll have, well, if there were 15, okay, let's say it's 15, okay, 15 people on this side, I have 30 arms of reading and 30 for B. But under 30 in the room, and if everyone did A and B, I would also get 30 A readings and 30 B readings. You get what I'm trying to say? So both designs do not have an advantage one over the other in terms of, oh, I get more data if I did it one way. But yet, let me ask you this question. Between the two study designs, which one do you think is better? They are both implementable. Which one's better? Anyone want to try? Which one's better? Study design one or study design two? Yes. Okay, can you tell us why? That's very good. So, yes. So the point is, study design one is better to implement. It's easier to do. But which one is better from a statistical point of view? Two. Can you give me a reason why two is actually better statistically? Not whether it's easier. Definitely what she said is absolutely right. It is harder to implement study two because it's hard to keep your hands separate. But why is study design two better than one? Statistically speaking, yes.
Um, but because it rules out the chance that like all of the people in one group could have like a specific reaction or health condition to the lotion. Whereas this one like designed to it reacts to both equally because they're the same person trying both.
I what she said, right? Yes, people react differently to lotion. Some people have skin that will be moist and nice, even if they rub sandpaper on it all the time. Life's not fair, right? And there are people who take great care of their skin and still have like alligator, okay, whatever. Okay. So the point is we all react differently. And so having everyone try both is more equitable, it's fairer, and it will lead to less bias in your study. Okay? So what's the moral of the story? Well, one, design is very important. And number two, the best design may usually be the harder one to implement. So one last question. Does anyone have any issues with design two? I did say, okay, listen to my words carefully. Everyone left arm or left hand, lotion A. Right hand, lotion B. In my words that I just said, do you have any issues with that? Okay, listen carefully. Left hand, A. Everyone's left hand uses A for 30 days. And then B on your right hand for 30 days. Anyone have any issues with design two? Are there certain things that you have issues with study design two? We have established that study design two is better than one, statistically speaking, but are there still issues with design two? Left hand A, right hand B for everybody. Yes.
I think if you're applying lotion, the opposite lotion with one hand, that could be weird. Kind of like both lotions on the.
Oh, okay. Well, let's do this. I can't believe I'm doing this, but rub like that and then like
Yeah,
that.
but you're still getting on this side.
Not really. You put it on your palms and then you go. Okay, so let's discount that. Feel like I'm in Costco giving a demo, right? But anyway, the point is okay. But do you have any issues with what I said? Like, listen carefully one more time, right? I'm like a magician, right? Um, uh, left hand, A. Okay, yes.
Because we're like trained, like our right hand is the one.
Yeah, you're getting closer. What about we haven't talked about hand issue of hand dominant hand. I'm sure not everyone in class is right-handed, right? So by me imposing that your left hand always uses A means that this hand, for most human beings, 90% of human beings, we underuse our non-dominant hand. And if this always gets lotion A, then that's not fair either, because the hand that you use more tends, I don't know, to get drier maybe more easily, something like that. So what I'm trying to say is that even though you think you have a good design, you could improve on it. And we have to think very carefully. But this is beginning to be a little bit nitpicking, a little bit, I would say. But it's an issue. Handedness, dominant hand issues are a thing. And so you have to think carefully about how your data will obtain. And can you improve on your design if you could? So that's kind of why I did this example. Okay, so a little bit of jargon before we move on from this. An observational unit is the thing on which you get your data. Sometimes it's human beings, sometimes it's animals, sometimes it's a plant, but sometimes it can be abstract. It could be an attempt. Let me put it this way. An observational unit is anything you observe, but you don't just always observe a thing. Sometimes you observe an abstract entity. Let me give you an example. If I did a free throw, each of my free throw attempts is an observation unit. You're observing me doing a free throw to see if I made it or not. That makes the free throw an observation unit. Is this clear? So observation units are not always physical entities. They could be abstract things like a trial, but those can be observation units as well. A variable is the thing you record on an observational unit. So for example, if If you are an observational unit, I could record various things from you. I could record how tall you are. I could record where you were born. I could record your favorite color. I could record what year in school you're in. You know what I'm saying? These are all variables. And if my observational unit is something abstract, like a free throw, what can you record from that? Well, you could record a bunch of things. You could record the angle in which I threw the free throw, or you could record whether yes or no. Did I get it into the basket or not? So these are all variables, all right? So variables are measured on an observational unit. So if your observation unit is a person here, it could be things like height and weight and year in school. Why have I chosen these three examples? Do you see a different status in variables? Can variables be of a different kind? Like, what's the difference between these variables, height and weight, versus something like year in school? Anyone care to tell me what do you think the difference is? They're all variables. You measure them on people, but what's the difference between year in school versus something like height or weight? Is there something, even if you can't tell me the technical word for it, but can you describe why these are different in some way? Why is height and weight kind of different from year in school? Anyone want to try? What? Yes.
Because it's not a set number, there can be decimal points like after.
Yes. So let me refine that. So height and weight are what we call quantitative variables. They as you said, they can have decimal. They are measured on a continuous. Whereas year in school, although actually in America it's a little bit easier to teach this, because you don't use numbers for year in school. You say things like freshman, sophomore, junior, senior, things like that. It took me so long to get these down because we don't talk like that in Malaysia where I'm from. We just say you're in year one, right? Or year two. But here they use names. So basically, anything that you give a label to that puts people in buckets, that's called a categorical variable. See? Even if you numbered your year in school with numbers 1, 2, 3, and 4, the numbers don't actually mean anything. They're not a size. Someone in year one in school is not smaller than someone in year two. And it might not be an indication of time anyway, because some people come straight into year two. It's not an indication of how long you've been in school. It's just a tag. So a variable that's just a tag is called categorical, okay? So a quantitative variable is a variable that takes numerical values. And when something is numerical, it makes sense to do arithmetic operations. You can add people's weights together. You can subtract one weight from another. And you can find an average weight, things like that. Whereas categorical variables, a variable whose outcomes are category designations, it does not make sense to add categories together, right? You can't say favorite color blue, favorite color green. You can't add blue and green. It doesn't mean anything. They're just tags. So a variable that's just a tag is a categorical variable. They're all variables. You measure them on people. As I said, one person can give many variables. You can ask them what their favorite color is. You can ask them how tall they are. You can ask them if they are born in Michigan or not, things like that. And you see, so there are various kinds of variables that you could have, but they are broadly classified into whether they're quantitative or categorical. These are very, very important. Actually, today's class is an important one. It's a lot of very basic stuff, which I want you to distinguish between. What's the distribution of a variable? It's just a pattern. What does it look like? And so you can plot it on a graph or some kind of a display to see what kind of values you got. But we'll more on that later, all right? Okay. So when a variable is categorical, it is important to count the number of cases in each category. Let's say I asked each of you what your dominant hand was. Okay, what kind of data would I get? Well, if I went around the class and asked people, tell me your dominant hand. So I might get responses that were left, left, right, right, right. You know, as I asked one by one. So let's say we got these specific statistics from this class. Okay, let's pretend that I did this. Let's say I got 4 of you saying that left was your dominant hand, and 24 said right would be your dominant hand. What's not to understand about this kind of thing? Right? It's really basic. So I went around the class. 4 of you said left was your dominant hand. 24 of you said right was. Now, with data like this, Anyone care to suggest what kind of displays have you learned up to this point in your life that you could use to display data like 4 left, 24 right? Anyone want to try? Any data display come to mind that you have seen before, or maybe even drawn yourself in school or something like that? Anyone have any idea? 4 left, 24 right. How would you depict data like that? Yes. Yes, good. A bar graph, good. And I'm so glad you didn't say histogram because that actually would not be correct. Bar graph is the one. Bar graph is the recommended kind of bar chart, bar graph. Uh, there's something also known as a pie chart. I think you've seen Google Sheets loves pie charts, right? Pie charts are a little bit frowned upon. I'm not too sure why, because I don't have a problem with them, but people, it's fallen out of favor somehow. But bar charts I guess bar charts are a little bit easier to visualize, maybe, but they are equivalent, right? They basically angles represent how much of something there is, and bar heights do the same thing. So let's do our first. Can someone tell me, can you calculate the observed proportion of left-handers in our class? Now, I'm not going to ask you to do it right now, but can you tell me if I, okay, first of all, do you know that a fraction is, what am I saying? Okay. Do you know that a proportion is a fraction? Right? A proportion is a fraction. And this, I would tell you, is where some students abandon the course. I'm not joking. There are some students I've had who cannot answer this question. Now, if this is you, I don't want to, you don't know, I don't know if this is you. So I'm not trying to make anyone feel bad. But if this is you, please come and see me and I'll help you because you do need this level of math. You know, like in roller coaster, you must be this high to be on the right, you know, that kind of thing. Right? You need to know how to do this to succeed in this class. If this is a problem for you at this stage, you need to come talk to me and we'll work something out. Can someone tell me the fraction of people that are left-handed in this class? Something over something. What are the two something? Yes. Okay, that's a good try. Is it 4 out of 24 or does someone want to try something different? Yes. Yes. And how did you get 1 over 7? What did you do to get 1 in 7? Because 1 in 7 is not intuitive from this. You must have done something else. So, yes. Yeah, okay, good. So the answer is 4 out of 28, which is 1 out of 7. So the first point I want to make is the more important one. 4 out of 28 is the answer, not 4 out of 24. But thank you for trying because when you calculate a proportion of something, you need to find the total of every one that you're considering, then the criterion that you're interested in. Okay, that's a good try. Good. There's a fraction, it's 4 out of 28, which of course converts to 1 in 7. Now, this is a stats class. I actually prefer it that you don't tell me the answer is 1 out of 7. I'll tell you why. 1 out of 7, while numerically is equal, is less informative than 4 out of 28. Does anyone know why? Why is 1 out of 7 a I don't know, it's not wrong, but why is 4 out of 28 a better answer than 1 out of 7? I know this is not what you did in school. Okay, when you I don't know when you learn how to reduce fractions, middle school, maybe, right? I'm sure your middle school teacher told you it's like some kind of a huge sin to leave an answer as 4 out of 28. You must write it as 1 out of 7 or you lose points. Right? This is a stats class. I actually don't want you to reduce things, and that's not the focus of this class. Why do you think I don't actually want you to answer as 1 out of 7? 4 out of 28 is actually better, yes.
Because the 28 gives you like the total amount in class.
Yes, because 4 out of 28 reflects the sample size of the class, which is 28. See, when you reduce it to 1 out of 7, you have actually lost that information a little bit. So I actually prefer 4 out of 28. Or, okay, so this is just to make sure that we are on the same page when it comes to calculating a proportion. So the answer is 4 out of 28, which of course you can work out as a decimal. So as I said, we will be using calculators in our class, and I will usually encourage students to report their answers to 4 decimal places for homework or stuff like that. But you know calculator practice, right? If you're going to get something accurate to 4 decimal places, try to work with at least 6 in all intermediate steps. Don't always work with 4 and then expect your final answer also to be 4 to be of the same accuracy, because accuracy is a strange thing. You need to work with a little bit higher. I would recommend 6, but your final answer, usually we try to adopt 4 in this class. Okay? Okay. So if I asked everyone what your height was, for example, what kind of answers would I get? Well, in inches, you might see something like this. If I went around the class, 68 inches, 72 inches, 70 inches, whatever. How would you display data like this? Anyone want to give me a name, a word? What kind of graph is well known for displaying data that is quantitative like this? This is not left or right-handed kind of thing. This is quantitative data. So anyone want to give me a name of a kind of display that you may have heard of that can be used to display data like this? Yes.
Is it like called a line chart?
I think I know what you're getting at.
Like it's like a thing at the bottom with a bunch of numbers on it?
Ah, okay. He needs a dot plot. Yes.
Okay.
A dot plot is a way, and we'll talk about that. There's one other design, one other display very famous as well, such as an H. Yes. Here's histogram or something like yes. So that now is the time to say histogram because the data is quantitative, and I think all of you kind of know what a histogram looks like. So histogram, a dot plot, things like that. Good. So we got both from the class. So observe that quantitative data that comes from a variable like your height is different from count data. Now this is a point of some confusion to the class as well. They think that, didn't you say that count data is categorical, and categorical there's no number? Well, the variable doesn't take a numerical value, but once I have the variable, can I count how many people are like that? Of course. So just the fact that I know there's 4 left-handers in this class doesn't make that a quantitative variable. It's not like 4 is a quantity and 24 is a quantity and things like that. So therefore, it's a quantity. That itself doesn't qualify as a quantitative variable. Yes, there are 4 left-handers in this class. That is a number. But it is not considered a quantitative variable because that's not how you answer the question. So I always tell people the way you know if something is quantitative or categorical is how would you answer the question? If I asked you, what is your dominant hand? What answer would you give me? Left or right? The kind of answer you give is what classifies a variable as categorical or quantitative. Am I making sense here? If I asked you how tall you were, you'd give me a numerical answer. If I asked you what is your dominant hand, you wouldn't say 68. What? Okay. And if I ask you how tall you are, yes. What? I didn't say, do you think you're tall? I didn't say that. That's another question for another day. How tall are you? Yes. Right? No, you don't say that. So how you answer the question tells you whether a variable is quantitative or not, or categorical or not. All right. Not that I can count how many cases there are. That doesn't make something quantitative. All right. That's very important. Okay. So what advantage does a dot plot have over a histogram? So I don't have the answer on the slide. Let me ask you, what advantage does a dot plot have? Okay, so here's a dot plot. Here's a dot plot. Here's a histogram. Anyone know why a dot plot can be considered superior to a histogram? This one is low stakes. I don't really expect you to know the answer, but it would be a nice surprise if someone did. Like, why are dot plots a little bit more favored than a histogram? They are more modern, right? You won't find this in older statistics. This is very old. Histograms are very old. Why do you think a dot plot is considered slightly better? Anyone know why? And by the way, this is you can see this in your notes. This is how long the Super Bowl national anthem performance took. Okay, singers vary a lot from one to another. Some take a long time to finish the anthem. Some finish it faster. So basically, this is the data. All right. Anyone know how what I'm trying to say? Why is a dot plot considered? Yes. Yeah, it is. It's very good. The dot plot retains the data. A histogram doesn't. A histogram has binned people into buckets. So You are in the 100 to 110 second group, things like that. Both dot plots and histograms give you that overall shape, if you like. And here's another advantage. You see, a dot plot allows you to even distinguish between male singers and female singers. A histogram, you have to draw two different histograms and things like that. Okay, so dot plots also give you the shape. You can kind of see, oh, okay, most people are around here. Some people really take a long time. You can also see that female singers tend to take a little bit longer than male singers and things like that. So there are things you can draw from a dot plot that you probably don't get as easily from Instagram. Neither is wrong. Okay, it says that dot plots are very popular now. So the shape of a distribution is the characteristic of what it looks like. Does it have is it symmetric? Is it U-shaped? Does it have two mounds or whatever? So all these things are considered shaped. All right. Or is it uniform? And things like that. The center of a distribution is a middle or typical value of a quantitative variable. Can anyone give me a very common measure of center, which you have probably heard of? I don't think there's anyone who comes to college who doesn't know this word. Starts with an M. Measure of center. A very common measure of center. Yes. The mean. Yeah, good. MEN. The mean. Yes. Right. That is a very famous measure. Anyone know any other measure of center that also starts with an M? Less common than the mean, but you probably have heard of this one as well. Yes. Anyone? Yes. Yes. Also starts with an M. Anyone heard of? Okay, this is the least common. Also starts with an M. Yes. Wow. Good. Okay. Sorry. Maybe I actually had some M&Ms just now. I don't usually have M&Ms, but someone had a birthday cake and it had M&Ms inside. Anyway, the colors on them scare me to death, honestly. What, yellow number 5 is it or something? Anyway, so a very common measure is the mean, right? Another common one is the median, as you have said. The mode is the least common, but yeah, now, which one to use when we will talk about these things later? But they are all measures of center. Every or almost every data set has some display of variability, okay? And a very common measure of variability is a range. Why? Because the range is easy to understand. A range is maximum minus minimum. Who's the largest? Who's the smallest? What's the difference? That's the range. But there is a very common one that's used as well. And I want to ask you, does anyone know what I'm getting at here? Have you heard of a measure of variability from any of your other classes or from school that you might have heard of before? This is not a measure of center. It's a measure of how variable your data set is. Yes. Yes, the SD. Very good. And the SD is a very, very common one. And okay, so very good. Okay. Now this is a very, I would say today's class is really very important. I am recording it. And so, I would actually recommend maybe in week 5, you actually review today's class. I think because a lot of very basic things which I say today will be used again and again for 15 weeks, believe it or not. So today's class is extremely, extremely fundamental. And so I will package this as something that you can access and you can view it anytime you want.